Meta AI just released a new chain of thought approach that outperforms OpenAI's O1 model by excelling in not just mathematics and science, but also other domains like marketing, health, and general knowledge. This new approach is called thought preference optimization, and it doesn't require any human labeled data. And you can implement it right now using Hugging Face alone. So let's get through this paper now.
Hello everybody, welcome back to my YouTube channel. Today we have a pretty solid paper right here from Meta Fair from Facebook. Essentially, so I saw this paper like just now from a Reddit post, and apparently this AI paper is released just like three days ago, right? So it's about thinking LLMs, general instruction following with thought generation. So it's from Facebook AI. And now let's see what it's about. So LLMs are typically trained to answer user questions or follow instructions similarly to how humans would do. However, in standard alignment framework, they lack the basic ability of explicit thinking before answering. Yeah. Yep. So that's kind of like what the O1 is trying to do, is it? So thinking is important, yeah, but it requires, for complex questions that requires reasoning and planning, but can be applied to any task. Okay. So, right. And they propose a training method for equipping existing LLMs with these thinking abilities for general instruction following without the use of additional human data. That's pretty good. Okay, so without the use of additional data, let's see what it is. So they achieve this by using an iterative search and optimization method, right? So iteration and optimization that explores the space of possible thought generations, allowing the model to learn how to think without direct supervision. Yeah. So this is already kind of sounds familiar to the strawberry model from OpenAI, but let's see what they have. So for each instruction, the thought candidates are scored using a judge model to evaluate their responses only. Okay, wait, hold on a second here. So for each instruction, the thought items, right? I just call them objects. Okay, the thought objects are scored against a judge model. Is that a reward model? Maybe. So okay, so a judge LLM probably right give a score for each thought. Okay, and then they use the scores and the thought text into a preference optimization algorithm. I would assume it would be DPO, direct preference optimization, and they show that this performance leads to superior. And this procedure leads to superior accuracy on alpaca, eval, and arena hard, and shows gains from thinking on non-reasoning categories such as marketing, health, and general knowledge. Wait, hold on a second. Hold on. Wait, and then and this is pretty interesting right here. It says that okay, so their method improves even on non-reasoning categories. Okay, right. That's really interesting here. Because, okay, I'm just going to type it here. So this is contradicting what OpenAI O1 uh, uh, O1 achieved, right? Right. O1 only improves on reasoning categories, but not on non equals to reward model. for some reason. It could be that. Okay, right. So now let's go through the introduction. Okay, so LLMs are based on the transformer architecture and predicts the next token at each step, blah blah blah. So okay, yeah. So when they are prompted, they have a fixed compute budget to generate the first response token, regardless of the complexity of the instruction. So a way to increase compute budget for harder instruction is to allow the model to think internally before outputting an response. I think you mean a response. Okay, this is similar to humans. Okay, so for those of you who might not know, so if you check out on Hugging Face, right? If you go to datasets, there's a pretty popular dataset right here. So as you can see right here, they provide the user query, right? Follow with the reasoning tokens and the output tokens right here. So presumably, right? Yeah. So this data set is kind of related in that sense. So what they're trying to achieve here is that instead of constructing a mapping of from the query directly to the final output, they argue that okay, if we have another set of query that is specifically for reasoning, right? Reasoning, like thinking in depth about what the user is asking for, right? And maybe that could help, right, in improving the accuracy of its own output. So so let's continue. Okay. One approach is to generate thought as text. Okay. And this is usually done using chain of thought, which we already know by now. And to say, okay, however, right, the usage of chain of thought is mostly useful for math and reasoning tasks, right? So for things like literature and other stuff, right? Where where I would hate to say this, but yeah, I don't really quite understand why chain of thought wouldn't help for other tasks other than mathematics and reasoning, right? But it is what it is, you know. So okay, so someone found that chain of thought is unhelpful on tasks that do not require math and logic. Probably something like literature, but I do not know why. Okay, so in this paper, they focus on general instruction following, right? So they are saying that okay, their approach here is not just applicable for mathematics and formal logic, but it's also applicable to the entire field of human knowledge. That's what they say, right? So it has a broad utility. So thinking is broadly useful. They argue here. So let's see. For example, in creative writing tasks, internal thoughts can be used to plan a world structure and characters. That's true. I mean, like for example, right? If you're writing down a novel, right, it is important to make sure that there is a logical flow between each scenes, right? Other and I'm pretty sure that would require some kind of a chain of thought, to be honest here. Yeah, I usually struggle with literature writing because like there's a lot of process, right? There's a lot of context and content that you need to take into account when you write every single word to create a coherent and interesting story, right? And I think that that's one part which the chain of thought process would be really nice, right? But yeah, and that's why I don't really agree with the previous studies that only say that mathematics and formal logic are the only tasks that that's gonna be helped by using the chain of thought process, right? So right here, okay, and to say, okay, in other tasks, internal thoughts can be used for understanding the user instruction better. Yeah, that's true, right? As we can see right here, you see, right? Let's break down the problem step by step and reason through it, blah, 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 understanding the problem, and so on and so forth, right? So that's something that can be done. And it has been done already, right? So, of course, it is likely that less thinking is required for simpler tasks and more thinking is required for harder problems. So, they hypothesize, right? So, and this is their big hypothesis here is that thinking LMs will have an advantage on all sufficiently complex tasks. The emergence of the O1 model also support our motivation, right? In in some sense, it's their competitor in this case. Okay, and to say next. However, it is challenging to train a model to think, right? It's difficult because there's a few problems here. So there's a lack of supervised training data. Okay, wait a second. Let me see. Oh no! God damn it! I forgot to share the screen. Oh no! Sorry, guys. Oh man. Damn it, my key bindings. Oh man. Ah, okay, right. Yeah, as you can see right here, yeah, I made some notes right here. And for those of you who's like watching right now, I'm so sorry about this. I'm so sorry. Yeah, but essentially, yeah, if you have been listening to me, yeah, so I'm just narrating stuff out and then and then convey my own personal thoughts about it. But yeah, yeah, let's just forget about that. Let's just imagine that I showed the screen right here before. Okay, so, all right, although pre-trained data does contain valuable information, it can be limited to certain domains, right? As internal thoughts are often omitted in human writing. About this, um, yeah, so about this part right here, I don't think so. I would argue differently, pal. Because like if you read like a couple of like novels, right? Oftentimes, right, they will have these like stories in them, and it's very yeah, and it's very common for the authors to write about what the characters are thinking, right? So in some sense, right, the AI model is going to learn how to have internal thoughts using that kind of training data, right? So I would argue against that, you know. But anyway, regardless. So existing post-training data sets typically consist of human responses or preferences over responses. So something like a ranking of responses, right? So with no information on thought processes. Okay, yeah. So, and this is true for existing reward models, combined with the difficulty and cost considerations on collecting human taught data. Okay, of course, it's going to be expensive, right? So, there's a couple of bad stuff happening here, but we shall see how they fix, how they mitigate all of those things right here. Okay, so okay, so the goal is to investigate whether or not it's possible to convert current LLMs into thinking LLMs or fine-tuned LLMs, right, without additional data. To this end, they introduce, ta-da, right here, sorry, I just burped just now. Okay, TPO, thought preference optimization, right? So it further trains an instruction-tuned LLM to make it capable to have internal thoughts, which is something like the what is it called? The reflection AI model, right? The 70 billion model, right? But it turns out that it doesn't really work that well. But in this case, right here, it's gonna be different, right? Because there's RL, there's gonna be reinforcement learning in place here. So okay, their method is quite simple. Let's say, all right, let's have a see about that. It reuses many parts of existing training pipelines. That's true. Like you can already perform DPO using Hugging Face, right? So okay, so the LM is first instructed to produce an output sequence that can be divided into thought and responses. Okay, so LLM, let's see, LLM can have thought, responses. Okay. Okay, so the top part is considered internal and not part of the response shown to the user. Okay, and to say that we don't show the top part to the user. Ah man, yeah, exactly like how OpenAI did, right? You pay 96% for the tokens. I mean, you don't get to see 96% of the tokens that you pay for, right? But okay, so they optimize this top response output through RL, right? And they use a judge model. I would say it's a reward model to evaluate the responses and judge the quality of the thoughts by induced responses. This does not require human curated thoughts or special judge model. Okay, so right here, blah blah blah. Yeah. Okay. I would. Okay. Honestly, though, I would be interested to see if. Okay, because I heard that this paper applied this TPO approach to set an 8 billion parameter model, which is their Llama 3.2, I think, or 3.1, right? And I really hope that they don't have to use a larger model as the judge, because that would kind of defeat the purpose. I mean, kind of defeat their one of their selling point of their approach here. But let's see. Through preference optimization, the thoughts are then optimized to improve the resulting responses. This contrasts with recent works such as Schnell and Kumar, which uses additional supervision signals to guide them for self-correction, self-refinement, instead of directly guiding the. Okay, right here. I think this is important right here. Okay, so instead of directly telling it how to think, we just let it like figure out how to think, right? I mean, at that point, it doesn't have to be English anymore, but yeah, I mean, if it works, right? But okay, so so there's a lot of evidence that show that Cod is really good for logic-based tasks, right? But here they focus on general instruction following instead. New idea is here. Sorry. Okay. We train on diverse user instructions and evaluate. Okay, just give me 1 second here. Just give me 1 second here. Sorry. Okay, sorry about that noise. Okay, we train on diverse user instructions and evaluate our models on those benchmarks, right? And they get a win rate of 52.5 and 37.3%. Yep, much better than just your typical LLM that does things without explicit thinking. And they also conduct more fine-grained evaluations to determine what kind of instructions benefit from thought. Yep, and they say here, right, right, which they mentioned before in the abstract is that thinking benefits both reasoning problems and also non-reason problems like general knowledge and marketing and health. So, yep, and that's their novel contribution here is that chain of thought can improve a lot more things than just mathematics, right? And coding as well. So yeah, take that OpenAI, take that, suck it up. But okay, so before we go into the methods there, let's go through the conclusion real quick here. So wait, hold on. How to drink? Okay. Right, let's do this. So in conclusion, okay. So they introduced thinking LLMs. Why? Oh yeah, yeah. Why do they call it thinking LLMs? Just call it like LLMs. Oh, never mind. Okay. Which think in natural language before writing. Blah 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 blah. Okay. 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 So we provide incentives for the model to generate its own thoughts without explicitly teaching it how to think. Okay. So it's like as long as you can get to the other side of the road, whatever you do in between doesn't really matter. That's what they're trying to do in this paper. So, okay. And the results on benchmarks show that initial seed model and first iterations of training perform poorly compared to direct response model. However, after multiple iterations of the TPO, their method outperforms the baseline, right? So, right. And that's some additional information from the conclusion passage right here. Not so much, but let's go through the limitations here. Okay, so they experimented with two kinds of thought prompts and observed some performance differences between them. And they say it is certain that certain thought types are suited for some of them and some for the others, right? So so you really just have to like go through each of the different type of prompts and try them out and see if it works good for your own application. Okay. And therefore, training on the diverse set of thought prompts and allowing the model to switch between them could be useful to further improve the accuracy, right? Okay. So yeah, and you will also think that maybe the prompt, maybe this prompt thingy, right? Maybe it can be further optimized. Maybe you can have like another model that's like responsible for like generating good prompts and then feeding the best prompt for the model to use, right? But obviously here, right? Okay, and this will allow the model to better explore the space of thoughts, right? But obviously they have not conducted these experiments. Okay, but I would say they could have been conducting these experiments, right? So yeah. So okay, let's see. Okay, and they say here, yep, improvements in overall performance by using TPO, evaluation on GSM 8K. Wait, what the heck? No way, no way. You're telling me this now? Thank God I look into the limitations. Man, I just got bamboozled here. Or am I? Okay, so it kind of suck on GSM 8K. Okay. As they discussed, this is likely due to their setup not oriented towards such tasks. Incorporating more math instructions during training and having access to a judge capable of evaluating their answers. Uh, mm, Okay, so you're telling me that now it's the other way around? No way. So you're telling me that okay, right. So the previous works, so the previous papers, right? Let's say that, oh yeah, chain of thought is excellent for mathematics, right? But it kind of doesn't really help for the non-reasoning task. And now you're telling me that your chain of thought method is useful for the non-reasoning task, but it kind of suck for the task that requires so much reasoning. Oh man, I just felt like really confused here. This is really confusing. Okay, so in the current version of the method, thought lengths are purely determined by the model itself. There is no steerability in terms of like controlling how much thought tokens should be used. Adding such functionality could be useful as longer thoughts requires more computation. Yep, and that's exactly what we see with OpenAI, right? So, so what OpenAI did, right, is that if I'm not mistaken, right, although I haven't tried to use it myself, but it's kind of like, understand how complicated the user query is right, how complicated it is, right? If it's really complicated, then you might need to use like, I don't know, 100,000 tokens of thinking, right? It's right. So they've already done that, right? And I don't see this being a difficult issue. So moving on. Okay. And here comes the sexy part right here for me is that all of the models that they use are only 8 billion parameters. And that's pretty cool, right? So obviously, OpenAI doesn't use 8 billion parameters, but it's really cool to see that this kind of like chain of thought process is also applicable for the smaller models, right? Right? It should be, right? Right. I hope the judge model doesn't require something that's larger than the 8 billion parameter model. I hope not. I hope not. I hope not, man. Cause like honestly though, I want to use this approach. I want to. So okay, let's see what they have at the bottom here. Blah 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 blah. So here's some prompts right here. I mean like I will have a look into it myself if I want to implement this. Right, but okay, so there's some internal thoughts here. Right. Oh man, this is so funny here. Wait, hold on. My laptop is lagging. Okay, here it is. Right. So write a program to compute either scores of a chess tournament and the internal. Oh, oh boy. Oh boy, this sounds like a challenging query. I hope I can break it down into manageable parts. I will need to understand what the rating system is, then design a program to calculate the ratings for each player in a tournament. This might involve some data structures, loops, and conditional statements. I will need to consider each cases, blah, blah, blah. Okay, and it has a draft response here. Here is a possible approach. The program will require the following inputs. Blah, 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 blah. Okay, so that's the draft thingy right there. And then here comes the evaluation. Okay, and it evaluates on its own response here. This response is a great outline of stuff here, but it doesn't have specific implementations such as that, and that. And the final response is here. So this is the code. Okay, that is very interesting. The fact that, right, what surprises me right here is this kind of like emotional statements here, right? Apparently, the this TPO process somehow encourages the model to have like this very expressive state statements in its chain of thought, right? Hmm. Let's see. Okay. Okay. And the direct baseline failed to answer the question correctly. Okay, that's okay. Overthinking. Okay, example of overthinking here. Okay, let's see. Internal thoughts. Okay, blah blah blah. That's an interesting combination. Okay, but it's not really efficient. Wait, what? That's a terrible idea. Let's start fresh. Blah blah blah. Still not perfect. Okay. All right. So right here. Right. So apparently, right, if you let it think too much, then it will be kind of bad in the long run. So, okay, so overthinking is something that's not good, apparently. So let's see, next. Instruction. Okay, blah blah blah. A number is that in hex. Okay, what number is it in decimal? Okay, so this is right. Example of thought process helping, but still incorrect before training. Okay, so that is before training. Okay, so example of process helping with self-correction in mathematics. So, okay, so let's look at the thought process here. So start off with a draft response. Okay, here. Here you see right here. Okay, wait, this can't be right. Profit is usually a positive value, not a huge sum exceeding the internal investment. Okay, and its own evaluation. Something's off. The calculation looks correct, but the results seem absurd. Profit should be a reasonable amount, not nearly 10 times the initial investment. I'm missing something. Maybe I should recheck the mathematics or rethink the approach. Ugh, I hate when I'm unsure about what. Okay, why is the algorithm encouraging this sort of statements here? Is it like efficient? I mean, like, wouldn't it be best to like get straight to the points that you want to have instead of like having this like unnecessary emotional text, if you will, right? Maybe I could be wrong here. I don't know. Comparison of responses generated by direct model and TPO model to a question from the test set. Initially, it makes an error, right? So it makes an error at first, but corrects it. Okay, this is sounding a lot like the strawberry model already. So, okay, so the final model response length, right here, blah, blah, blah. Okay, so obviously, obviously, right, if you're gonna, okay, I do not know what generic and specific means in this case, so I'm not gonna comment on that because I haven't gone through the methods, but right now here it comes, right, here it comes. So, okay, let's take a look at figure one here. So this is their main dish of this paper, if you will. So they started out by prompting the LM to generate thoughts before its responses. Okay, so this is the prompt telling it, okay, generate this, right? And then you generate the response. So, and what it did next is tell it to sample different outputs and then feed the response parts to the judge model, right? Which determines the best over response. Okay. Not so sure what the judge model in here is exactly, right? So, okay, and they use the corresponding full outputs, right, as the chosen and rejected pairs for DPO optimization, and then repeat this for multiple times. Okay, so that's pretty simple. right? So they feed the response part to the judge model and determines which one is the best one, and then they use the full output as the chosen. Wait, hold on. Ah, okay, right. I see it now, guys. I see it now. Okay, right. So if we mathematically define it, right? So the judge essentially only takes the response, right? So that is exactly what the judge is going to do. It doesn't really care about the thought process, right? Okay. Wait, guys. Wait. So as you all might know, right? Guys, ah, why? Why is OBS? Man, do you know what? OBS is I do not know why. Probably because I misclicked some keys, man. It just pauses the entire thing. Like I was just writing things down, and it just pauses it, right? Oh boy, oh boy. Okay, right. Man, okay. You know what? Do you know what? I'm in a bad mood now. So what I'm gonna do right now? Okay, right. So okay, I can't believe I have to go through this again. But anyway, right. Okay. So the approach works by having you as the user going to okay, so asking the LLM to think before giving an output, and then you feed your own user instruction to it, and then it will produce its own thought tokens as well as the response token after that, right? And then you feed the response tokens into the judge LLM to choose whether or not your response, whether or not the entire output that the LM generate is going to be a good one or a bad one, right? The good one being the chosen one and the bad one being the rejected one. As okay, right. And then what you do next is that after knowing that which one is going to be the chosen and which one is going to be the rejected one, you take the entire output, right, which includes the thought and the response, right? And you feed it into the DPO algorithm, which you can obviously do on Hugging Face, and you let it cook. So that's the entire thing right there, right? And I'm not so sure how much things that I have to explain more, but I don't think I have to. So okay. Oh man. Okay, right. And okay, as for this process right here, right? So the initial process of us asking it like, okay, right? How do you like ask it to think appropriately? So there's two types of prompts that they tested out. One is called generic, and the other one is called specific, right? So the generic type of prompt, right? It is basically it is like not really, it's not really guided, right? Right, that like you don't like how should I say, right? You don't like give it too much hints on what to do, right? You just tell it, okay, write down your thought process, right? But you don't say what kind of thought process would you need to use, right? Whereas in the specific thought prompt, you explicitly ask it to include a draft response and its own evaluation, right? So that's that. Okay. And obviously, I'm just going to get straight to the point. Obviously, this is going to work the best, right? Because there's self-evaluation and a draft. So that's that, right? And these are the things that you have to specify before doing anything else. Okay, There's a lot more stuff here. Okay, so there's a lot of things there, right? But let's see. Okay, so their methods actually start right here. And I sure hope that it's still recording. Is it recording? Yep, it is recording. That's good. That's what I want to see. Okay, so right, let's get into the let's get into the details here. Let's get dirty. Okay, so start off with a seed model here. Okay, right. So start off with a seed model, right? So it's an instruction to model, obviously, and you will need a data set of user instructions, right? And you will have to feed the instructions into the model, right? Which in this case would be the seed model, I think. So, okay, so for each training iteration, feed the instructions to the current model, MT, with our top prompt, right? Right. In this case, let's assume that it could be either the generic one or the specific one. So, plus, okay, so the addition operation here means that it's concatenation as input context to the LLM, and the sample k outputs each containing the thought and the response, right? So these are just like uh, notations just to rigorously define what you're doing here. Hmm. Okay, and now here comes the preference pairs. Okay, so they're talking about, okay, we need to feed the responses into a judge model to score the outputs, right? And I would be interested to see what kind of LLM they use for the judge model here. So for pointwise judge models that take in a response and output a scalar, this is the process, right? So you're essentially transforming this into a number. Let's say it could be a score of like 10 out of 10. You know, it could be that, right? It could be anything, right? As long as it's just a scalar. So they also consider judge models that take in a pair, right? A pair and output the winner, and they apply the judge model to all possible pairs. This includes swapping positions to reduce the position bias of the judge, which is something that I actually did for my own agentic system. Good to know that it's done in like actual research as well. So okay, once we have all pairwise winner, we will convert them into individual point scores. Okay, so and I think they use this approach, but I think it would be nice to like compare whether or not the single one or the pairwise one, which one of them would work the best, right? Maybe they have done it in this paper, but let's go through the next thing right here. Okay, so they chose the highest and lowest scoring as the chosen and the rejected samples, right? So this is the pair right here. Using this process, it can learn better. Okay, so there's that. Yeah, and they use DPO. Okay, right here. And they say they do not use data derived from previous iterations for training the current iteration because they are not so great. Okay, right. So all the data is just like from the original one. So there's no recycling in this case. I mean, there's no reusing in this case. Okay. Lang control. So, and they say that, okay, some judge models tend to favor longer responses. A Lang bias causes the response length to grow with each training iteration, resulting in an overly verbose model. So they have a new mechanism here, right, which I actually do not know. It's called Lang control mechanism. So it's a normalization function, right? So it's n taking in LKI. So it's some kind of a normalization function, and they recompute the scores by penalizing longer responses, right? And you have to include it in the reward function, right? So you have like the longer the text is, the less reward you are going to get. So obviously that's going to be a bit tricky, but it is just what it is. Otherwise, you're gonna have like a huge text output, and that's gonna like take a lot of time to output. All right. Huh. Okay. Right here. Here's the selling point, right? Llama tree. Okay. Oh, I see. So they're only using on like Llama tree 8B. So I guess this paper, although it's released like 3 days ago, I bet this approach, this test has been done like months ago, right? So okay. Llama tree 8B instruct scores around 24.9, but as soon as you add in a top prompt, it reduces a lot, right? But direct response baseline scores around 48%, but as soon as you use TPO, it gets increased up to 52.5%, which is better than a lot of the larger models. Nice job, Meta. Nice job. So right here, let's see right here. Okay, they compared their TPO approach against all of these things. Right, the latter which does not perform well, the user. Okay, right. So that's that. That's pretty nice. So let's see. Ah, guys, I found it. I found it. So apparently they use this model right here. Okay, so for the judge model, right? Okay, so for the seed model, they use Llama Tree 8B instruct, right? But as for the judge model, right, they have two options here. Either using a self-taught evaluator from Wang or the Armor reward model from Wang. It's the same guy. Anyway, yeah. So self-taught evaluator. Okay, so yeah, STE is like 70 billion parameter model, where okay, so given two responses, it outputs its preference in natural language after generating a code, right? So our real model is 8 billion real model that outputs a scalar score given a single response. Okay, right. So I'm gonna take note of that because I'm looking for a judge model as well. So thank you for that. Oh my god, why? Oh my god, guys. Right. So the judge model that they use here, right? So so this one is like 70B, and Armo is like 8B, 8 billion parameters, right? And somehow, if you compare it, right, almost scores better than STE, which is pretty insane. Like an 8 billion model surpasses 7 billion parameter model as a judge model. That's pretty good. That's pretty good. Okay, right. I'm gonna take note of that. It's better than STE. Like hell, dude. I'm gonna use Armor right now. That's pretty good. Okay, let's see right here. So blah blah blah. Blah. Yes, there's a lot of results here. All right, let's see. Yeah. Wait, hold on. This one right here. I can't see it. I have to like do this. Okay, right. I wait, hold on. So TPO. Okay, let's see how TPO works that well. Let's zoom in actually. Okay, so TPO wins fit around 56%, the highest one on research and analysis, not surprisingly. And the next one is language and translation, following by marketing, mathematics. Notice that marketing and mathematics are pretty close, and personal development, right? And there's art and design and travel and finally creative writing. Okay, right. So yeah, so as for the creating writing part, it doesn't really improve that well, right? Right, much like how the strawberry model did from OpenAI, it doesn't really like change a lot. But I think it does help a bit more, I think. Um, I mean, it improved like a lot of different tasks, right? Not necessarily just mathematics or physics or any kind of like those kind of things right there. Okay. Yeah, 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 blah, blah, blah. Okay, right. Internal thoughts here. All right. So right here, there have generic thought prompt and specific thought prompt right here. And I'm not gonna type anything this time because whenever I type something, it probably will mess up with OBS. So okay. So starting off with thought process, and here's my response. And here it's more elaborate internal thoughts with a draft response and evaluation. Hmm. Honestly, though, I'm not so sure how OpenAI did this thing with their O1 model. Because, like, I saw some secret chain of thought tokens, right, on Reddit, allegedly to be OpenAI's O1 thought process, right? It seems to be really unstructured in that sense. It seems to be more flexible than what we have here. Hmm. Maybe Desert did some kind of like more general optimization instead of like just like predefining, you know, the top prompt from the start. So blah blah blah. Yeah, and that's a lot of stuff here. Yeah. Okay, cool. Yeah, I think that's kind of about it. So, yeah, if you make it through this video, I'm so sorry. But no, actually, I want to thank you guys for watching this video, and I am super duper. Wait, is it raining outside? Oh, never mind. Anyway, yeah, okay, right. If you like this video, make sure to like, comment, and subscribe. Right. Because I noticed that a lot of people don't watch the longer videos, right? And I get that because like it's kind of like tedious to be honest here, but somehow, right? Somehow the YouTube algorithm, right, is like encouraging these like longer types of videos. Obviously, it's for like the ads, revenue, and stuff like that. But honestly, though, like, look, I'm just a small channel here. Like, yeah, yeah, I'm not here to make any kind of money. Honestly, though, yeah, yeah. But I feel like it's like get to like explain these papers to you guys, right? It also help to like force myself to like understand the paper even more rather than just like skipping everything else, right? Because like it definitely like forces me to like read through every single details and then see whether or not it makes sense, what are the tools and methods that they use for the research, right? Yeah, and I really like doing this with you guys right here, right? Yeah. So yeah, and make sure to check out my Patreon as well if you want to have access to my notes and also support this channel. Yeah, but yeah, stay awesome, you guys.